I am way delayed.
Yeah.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 228, Bats, Eggs, Lasers, Duct Tape, and Assembly Language. So first off, I guess I should apologize. Hackaday broke YouTube. What happened was we wanted to upload our back catalog to YouTube Music, and our syndication feed did not have a checkbox for not publishing them all, and we published all 220 whatever episodes all at once, completely clogging up everyone's subscription feed. Super sorry about that. If we're lucky, by the time this goes live, Tom Nardi has figured out a way to delist them all and still have them show up in the podcast playlist and hopefully also on YouTube Music. So we'll clean up your subscription feed and you'll be able to find the podcasts. Anyway, going forward into the future, we're just going to have one podcast a week. You'll get the announcement for it, but that's it. We are not going to denial of service your entire subscription feed ever again. Super sorry about that. This week in Hackaday news, we have the announcement of the Assistive Tech finalists in the Hackaday Prize. Now, this is a round that finished up way long ago, May 30th, and we had some technical problems doing the judging, but we got it out now, and it is worth the wait. I'll throw a link to Tom's really nice write-up of the winners in the show notes, but they include 2 Braille hacks, a bunch of audio hacks for deaf people, like audio sound localization hacks, pill dispenser robot, a really nice pressure sensing joystick for people with low coordination, whole bunch of really cool hacks. You should check them all out. Most of them are, of course, intended to help people with various disabilities, one or another, but they're all really great in their own right, and there's probably something for you there if you're interested in any sort of kind of sensors or actuators or, inputs or et cetera. What helps people who have limited mobility is actually really fun to use for people with full mobility too. So does double duty every which way, and go check these out.
Yeah, I kind of love that every time we do have a Hackaday Prize, there's always some variation on assistive technology category. And even if we didn't have a category like that, it seems like people just kind of gravitate to that kind of theme for projects, and I think that's great. I like seeing a lot of these, and I think it really pushes the limit and gets people thinking about what it takes to maneuver the world. I mean, like sense the world and be in the world and all that, and how you can't take for granted what you have.
Yeah, and I think it also speaks to the fact that a lot of hackers want to help other people out. And that's
Absolutely.
really, the nicest thing to do is make something for your friends that they really enjoy. Then even better than that, of course, is to make something for someone who really needs it. And I think that helps add a little extra incentive to it as well, right?
So what's the next challenge? Gearing up?
In between assistive and gearing up was actually the green challenge, and we're doing the judging now. That should come out as early as next week. And gearing up is still currently running, which is about making your own tools, and that will be going until August 8th. So you've still got a few more weeks to enter into that one. And then it's wildcard challenge, and then it's the final round. And then the 50 people, wow, already. How did that happen? Is it?
No.
It's almost fall? I don't believe it.
Stop.
And then the 50 finalists will finish their projects up, get their final entries in, and our crew of celebrity judges will pick the best hacks from among them. But it is worth noting that all the finalists get a $500 prize, and that ain't nothing. So congratulations to all of them in assistive tech. And stick tight for green hacks coming right up. And then hopefully, if we can slave drive our judges, we'll get the gearing up challenge done pretty quick too. And speaking of deadlines, this week was the official last day for call for proposals for Hackaday SuperCon coming up in November. We're extending the deadline. So you've got one more week. So if you manage to procrastinate your way out of this deadline, you've got one more week to enter a talk or workshop proposal for SuperCon, which is awesome because you get a free ticket if we pick you. So come on along, join us, give a talk. It's a great crowd. They want to hear what you have to say. I'll throw a link to the call for proposals page into the show notes as well.
This is a journey into sound.
What's that sound?
What's that sound?
This week is we read out your delicious answers and give people the prize week, which means, Dan, have a listen to it and see if you did as well as our audience.
This one's supposed to be hard.
Tom and Al did not like it.
They seem to be gleeful about my impending failure here, so let's see. Sorry, Tom and Al. I think I know this one.
All right, what you got?
I just want to make sure I got the right name for it. It's weird vocal synthesizer, voter, or something like that.
Oh, no.
No?
No.
No.
Good guess. I mean, vocal is right.
Is this the thing with like the creepy mouth, that like animatronic sort of vocal cord simulator?
You are getting very close. I don't think it's exactly creepy.
Not exactly.
I mean, it's definitely whimsical. But
it sounds like something that I wrote a story on once. That creepy sort of banshee sounds.
You're gonna actually have to go watch the video, because that's half the reason I picked this, is just because I think it's absolutely hilarious. So let me get you the link. I'll throw the link in the show notes as well.
Oh God, that's terrible.
Isn't that awesome?
It reminds me a little bit of that rubber chicken that was going around a couple years ago. You just shook it and it made all kinds of noise. But that's not at all even close to what I was thinking. So
that's not what you're going for.
Tom and Al, you win. I won't. I lost.
So the answer at home is it's Maiwa Denki's Automaton. You should definitely go check out Maiwa Denki's work if you haven't. He is a crazy inventor who invented this entirely fake electronics company and builds crazy things. And then he came up with this insane musical instrument. I don't know what. It's like a tennis ball with a slit in it so that when you squeeze it, it opens its mouth. And then you can play it by sliding your finger up and down a stick that comes out the back, like a ribbon strip theremin or something. And so you can make it go wah, 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 wah by squeezing this ball. And it's an absolutely, absolutely marvelous instrument, no matter what anyone else says. The video I've linked is the inventor playing Brazil for you.
I don't want people to think I'm making stuff up. There was a very strange vocal simulator.
Oh yeah.
And I can't find it now. I don't even know.
But see, you got that exactly right. The vocal simulator part is exactly what it's doing. It's opening its little plastic mouth, making it go wah wah wah. So
okay,
spot on. I think that's a perfectly valid wrong answer.
I'm proud of my wrong answer,
which I think that's pretty solid. But no, it was the Automaton, and we did get 39 correct answers.
Wow.
61 entries and 39 correct answers. So that's not bad. 2/3 of you got it right. How do we do this? I'm going to fire up Python, I guess. I'm going to import random. I could do random choice range 39. Oh, but then I have to add 1 to it because it's 0 indexed. Random choice range 39 plus 1. Congratulations, number 21. And number 21 is Jax, who said simply Automaton. Yep. Boom. Congratulations.
Good job.
Other answers include, that sure sounds like an automaton to me, although autocorrect thinks it's an ottoman. We have, I immediately thought about that Pac-Man instrument, which Google reminded me was called the Automaton Rubber Resonant Body Electrical Guitar Violin Thingy. Yeah. Code E, to automaton being played by an expert, or at least someone with practice. Yeah, indeed, it's inventor. So congratulations again to Jax. I'll get in touch with you and get you a Hackaday podcast t-shirt. Everyone else, stay tuned. Listen in next week. We'll play a new sound for you. And that brings us to the hacks. I'd like to start off with Omeni's listening to bats as they search for food. because I really like bat detectors, and this one is particularly neat because it not only listens to the ultrasound that bats put out, but it then down converts it for you so that you can hear it yourself. And that is really, really cool. And there's a whole bunch of ways to do that. And I just think the whole topic of how you take ultrasound and turn it down into like normal people audible sound is really fun. This one uses a Raspberry Pi Pico. It actually records the sound and you can down convert it two different ways. One of them is you can heterodyne it. So it's actually just like a radio would work. You mix an audio signal at like the bat's really high frequency with the bat's really high frequency, and then the difference between them is something that's lower in frequency that we can hear. And another one of these designs here actually records the sound and then just plays it back 16 times slower for you. So it plays the literal, whatever it is, 250 kilohertz sound way back down where we can hear it. I think that's pretty cool. Actually, there's a third design on O'Malley's page here. You should go check them all out. They look like they're easy to make and are all courtesy of the pleasant availability of high-frequency ultrasound microphones and MEMS microphones in particular that let you hear these kind of super high frequencies with actually nice listenable resolution.
I've got a bit of a soft spot for bats. In our old house, they'd come out every night, and as the twilight sort of gathered in and everything got dark, the sky was still bright enough that we could see them, and it was just like, fly, my pretties, fly, go eat the mosquitoes. And the mosquitoes were abundant, and we were just like, every time we didn't see the bats, we were like, oh man, the bats have gone. It's kind of depressing. I think it was Tech Minds over on YouTube did a bat detector using an SDR, which seems a little counterintuitive because it's, despite what David Letterman says, them bats ain't smart. They don't use radar. They use sonar. And I couldn't believe how high they went. I mean, even here, 350 kilohertz, you're darn near what you'd think of as broadcast AM, medium wave radio. It's a sound wave, not a radio wave. I get that. But still, it's just like, what in a living organism can produce that kind of sound? It's just like crazy. Anyways, these kind of projects are always kind of neat, and sort of the unseen, unheard world of bats.
Yeah, I think that's exactly what I like about it. Besides also sharing your feeling that bats are awesome, I definitely think it's really cool to, hear the unhearable, right? And that's exactly what these are doing. I'll link another one in Worried About Bats in Your Belfry, A Tale of Two Bat Detectors, which is a neat deep dive into the kinds of bat detectors you could build by Pat Wetman, who used to write for us, and actually also built a really neat AI bat type detection algorithm because, like Dan said, you can listen to the different frequencies and they actually make particularly different chirps as well, and you can discriminate what kind of bats you've got. On the totally other end, there is a hack like Build a Simple Bat Detector, which just uses a divide down detector. The advantage of the divide down detector, I guess, is that it works in real time. And what you do is you basically threshold the signal. So instead of it being a nice audio signal, it's all either high or low. And then you just run that through a frequency dividing IC. So, you just run it through a counter, essentially, and you pull off the fourth bit to divide by 16. And the sound you get out of that is this horrible, distorted version of what a bat sounds like, but at least you can tell if you've got bats around. And so, if the question is there activity in 300 kilohertz, this will tell you that, although it sounds like crap. If you want to actually listen to them and hear that they kind of sound like neat chirps and they make interesting sounds, these ones that O'Malley have are really cool. Yeah, so also based on the Pi Pico, but writing data out to an SD card is the Pi Pig or Pipig, or I'm not 100% sure how to pronounce it. But this one uses a thresholding thing to detect when there's a sound, and it records the sounds to the SD card. So you can just leave this out all night and it will record all the bats for you, and then you can pick it up the next morning and see what you got. I think that's particularly cool too.
First up for me is recreating the golden era of cable TV. I mean, I kind of missed the golden era of cable TV. My parents didn't get cable until I moved out. They also didn't get air conditioning until I moved out. I think they were trying to tell me something. But once they did and I'd visit, I would, and this was probably in the late 80s, early 90s, I would try to get my fill of all the stuff that I thought I had missed, and it turned out that I really hadn't missed that much. But for some people, there was a lot of nostalgia in being able to go back and watch TV in the way that we used to watch it, which would be channel surfing instead of streaming, and just sort of bopping around looking for something good to watch and resting on a channel until it got to be a commercial, and then you go someplace else. This device is, hardware-wise, is pretty simple. It's everything you'd expect it to be hardware-wise, although this is by Irish Crack Party, and he did a nice walnut. Most TVs back in the day were simulated walnut veneer. This is actual walnut wood that contains the screen and the usual Raspberry Pi and encoders and that kind of stuff. But that's not the important part. The really important part of this, the really hacky bit of this, is what he did to get the content onto this thing. The short story is a lot of thrift store visits with and looking for VHS tape collections in tag sales and yard sales and things like that, looking for stuff that would pass for that time period's programming, like they show Beavis and Butthead on the featured image here, which is a perfect example of what kind of content he's got. He really has everything here. He's got HBO and Nickelodeon. He switches to Nick at Night once the proper time comes around. I mean, that's another part of this whole experience, this whole look and feel thing, is that he's got the timing down so that ads come in on at the proper times, like quarter hours, and you've got an hour-long program that's actually 42 minutes of content and 18 minutes of commercials. Well, he's got them stuffed in there, and they're classic commercials too. He's even got Saturday morning cartoons. It's got a funny little bit in the video about how he would used to sneak down and try to watch Spice, which was sort of the softcore, channel that your parents never would let you watch. And his experience of watching it now is the same as it was back then. It's got the scrambled, kind of make out a little bit of the audio, and every once in a while see something, but you're not going to watch anything on Spice. I just kind of love the dedication to the whole experience here. I've probably got a whole bunch of VHS collections that I would be happy to donate to him.
You mentioned the ads, and my God, I was surprised by what percentage of ads show up there. But also, it's got couldn't figure out if that was for real or emulated or what, but there's a preview channel where it shows what's going on, and it's like, it's got that little scrolling up time thing. And I think it's legit. Yeah. I think it just, if you want to watch Mr. Bean, you actually have to turn the thing on at 6 p.m. or else it's no Mr. Bean for you.
Just like it was for us back then.
Good man. No, it's just really fun and an extraordinary bit of attention to detail.
Yeah, my kids, they're like, how did you take this back in the day when you had to wait a whole week for the next Star Trek episode or whatever? And I was like, well, that's just what we did, and now you can experience it too. If you build one of these yourself, you can see the same thing that we did, commercials and all.
My next hack is Andy's Machines Trebuchet Sends Eggs Flying. Andy's Machines is a fantastic YouTube channel where he does a lot of hobby metal machining and building really cool stuff. I think we featured some of his gear building exploits before. Here he's trying to build a trebuchet to enter into an egg throwing competition. And, it's a friendly competition, but it has rules. And the rules are the thing has to have a certain total weight, and it has to run on its own power, nothing other than the trebuchet weight, of course. And it has to throw the egg as far as it can. This is the second video in Andy's build series, and it starts off with how bad his initial design is, where his kind of most naive trebuchet can only throw an egg something like 6 meters. And so he's got this crazy awesome idea, which is since the weight can only fall so fast and has kind of, its God-given acceleration profile, that means you have to either work on the gearing of the arm that throws the egg to optimize it, or you can add a spring in. And that's what's really cool about this trebuchet, is that the weight stretches a spring and then hits a release pin that then the spring snaps closed and it throws the egg flying. And he builds this fantastic machine and, a lot of machining and welding and all this. And it goes a stunning 4 meters. So 2 meters shorter. And he's like, oh no, and has to optimize it yet further and runs some slow motion video and finds out that it's stalling halfway up its throw, because what happens is as the arm moves out, the sling with the egg in it is also moving out. And so it's got more rotational inertia. And so the spring's pulling with constant force, but it's pulling against something that gets more and more inertia. And so it actually stalls and slows out about halfway up. And this also leads him to realize that you don't want to throw at the top of the arc. You want to throw earlier than that. And so he has to rejigger the spring and play with a bunch of the different weights, and he gets it optimized so that the weight that drives everything just is barely moving when it falls down and it hits the trigger, and then the spring snaps shut. The spring is then fully discharged by about 45 degrees. The egg goes flying, and he gets 10 meters, which isn't bad. If you've got a while, you should go watch the actual competition, because there are some yet cleverer egg trebuchet designs in there. And, no spoilers, but his design comes in like 5th place or 6th place or something.
It's the contest aspect of this and not knowing where you're going to land, with the competition, and not knowing what the competition is doing that strikes me, because as in Boy Scouts, when we had a similar thing like this, it was a lot simpler, though. It was build a catapult. That was it. I mean, there were probably some rules which I was unaware of at the time. I was probably 11 or 12 years old or something like that. My dad and I went in the workshop. We whipped up a catapult out of wood, which is what the material we had to work with, and we just did it sort of seat of the pants. And everybody knows what a catapult looks like. It was wood and rubber bands, and we tested it a few times. Like, yeah, that's cool. Okay, it works. I had no idea how good it was going to work compared to the competition. And we get to the competition, and everybody launches their bean bags, and you get to me, and I'm like the last contestant, and I load up the little bean bag and I launch it, and boom, and it goes way down to the end of the hall that we're in, hits the back wall 10 times further than anybody else. We didn't do any optimization at all. I mean, it was just sort of seat of the pants engineering, and it just absolutely blew everybody away. The crowd went wild, that whole thing.
That's awesome.
Yeah, it was a lot of fun. First of all, because I won, but also because we built this thing and had no idea whether it was going to work or not, and it worked very well. So +1 for seat of the pants engineering, I guess. And that's not what Andy did here. It very much not seat of the pants engineering, very much precision engineering. He had kind of the same experience, except he seems like he fell in between, in the range of winning and losing there, somewhere in the middle.
Yeah, it's really cool. I'll throw a link into the video with the winners and all the other entries here. There's actually a lot more going on to trebuchet design than you think. Just from the physics, just from the amount of weight they had to drop, I think these are getting pretty close to the theoretical maximum distance out of them. So pretty cool.
All right, up next for me, brute forcing a mobile's pin over USB with a $3 board. This one gives me a little pause, because it makes you wonder, first of all, how good your password is on your phone. And it also makes you wonder just how easy it would be for cops or anybody else who got a hold of your phone to brute force your password. What's going on here is basically a realization that there are about 20, and this is based on academic research, there's about 20 4- and 6-digit passcodes that people tend to use for their phones. And that surprises me, since with how many combinations of 6-digit numbers are there? Somebody do the math. I don't know, but it's a lot more than 20. And I didn't realize that people were doing what basically amounts to patterns, or something they could do quick, like 4444 or 1111 or whatever. Those are very commonly used passwords. So this device, which is basically just a little DigiSpark USB board that can be plugged into the USB-C or whatever it is on this Android phone, and basically do keystroke emulation. That was news to me, that you could even do that. I didn't know that the USB port on a phone was quite so versatile. I mean, and as soon as I read this article, I was like, oh, I got to try that. And I grabbed a little USB adapter and a wireless USB mouse, put it together, and I'm seeing a mouse pointer on the screen of my phone. Yeah, I had no idea. And I didn't try a keyboard, but I assume it would do the same thing. I had no idea that was even possible. And this device, this little DigiSpark dev board, takes advantage of that. The code is ridiculously simple. He's got a GitHub, and you can go look at it. And basically, it is exactly what the title of the article says. It's brute forcing. It's just going through these ridiculously easy to guess password combinations and finding the one that unlocks the phone. Of course, I looked through them and tried to find my passcode to make sure that I hadn't inadvertently picked a popular one. I haven't.
1, 2, 3, 4. How did they know?
How did they guess that? I mean, there's a couple of levels of defense here. First of all, don't have an easy to guess passcode. I mean, you could look in the code and see what those are. You could read the academic paper that's also linked in the article. I mean, the other thing is that the article that this was based on says that the increase in security from going to a 4-digit passcode to a 6-digit passcode is insignificant. And in fact, in some cases, even makes the phone less secure if you put a 6-digit passcode in. Obviously, that depends on what that passcode is. If it's, 6 ones,
yeah,
it's going to be worse than a randomly chosen 4-digit password. But it was a lot of little details like that were unraveled in this. I mean, the first thing I thought of when I saw this is, well, isn't there some sort of, limit to the number of passwords you can put in? I thought that was a thing. But apparently not in Android anyways. That's something that iPhone does. After a certain number of failed password attempts that you can, or that the phone gets shut down for a while, and that slows down a brute force attack like this, but it doesn't stop it. Anyways, it was kind of eye-opening to see, how vulnerable your phone is to being opened by someone with just a little $3 dongle.
Yeah, so I was like, why did they limit themselves to 20? Why wouldn't they just start, brute forcing everything? And
right.
The answer is exactly what you say. There's a delay. You can only go so fast. And after some number of tries, and in their paper, they actually say it's configurable. After some number of tries, you get locked out forever. And so, they don't want to push that. And so that's why they limit themselves to 20. And if you go through their code, it's like, it's the dumbest code ever.
Yeah.
It sends the number, it calls delay for half a second. It sends the next number, it calls delay for half a second. It sends the next number.
There's no loops or anything.
And then it waits for a second, and then it tries again. And that really is the whole code. And it's a USB library, and it's that code, and that's all there is to it. I'm surprised that you can plug in a keyboard and unlock that way. They should really, if they just made you have to type it in by hand, if only the on-screen input were allowable, that would slow people down a lot. Of course, somebody with a robot arm would just, press on your phone anyway. So I guess it's not going to slow down the determined hacker. But this is just such a dead simple solution. Yeah, that's scary. I'm going to have to go check if my password's on this one. It wasn't 1, 2, 3, 4. I was kidding. Let's see if 2222 is on there.
And just for the record, I just now plugged my keyboard into my phone and unlocked it with my PIN number. So, boom, there you go. Real experiment. I'm not going to tell you my PIN number, obviously.
No, don't tell me your PIN, but that's really cool. And my last hack this week comes from Maker Lab Munich. This is a DIY laser for ablating metal. And they have built a 2-axis laser engraver that's strong enough to knock away the copper on a copper-clad board. And it does this by emitting a very short, very strong pulse in the green wavelength, which copper really wants to absorb. And so they hit it fast enough that it goes blat and you get copper gas out. What's really fun about this project is they take the building the laser head themselves part very seriously, and it's a really neat build. This is meant to be an open source and do-it-yourself project, and their instructions are very seriously good. And if you wonder what it takes to build a kind of heavy-duty laser, this will walk you down a lot of those problem points, I guess. One is that there are some parts of the laser mount that have to be very precisely machined, probably out of copper because they need to be heat spreading. It's got a do-it-yourself TEC, which is a thermoelectric cooler. This is a bunch of Peltier coolers and some heat pipes and fins and stuff to keep the laser unit cool. From a laser nerd perspective, one of the really cool things about this one is that it uses an infrared diode laser and then doubles the frequency of that and turns it into green. And that's actually how like all the common green lasers use, except to make these super short pulses, it uses another sandwich of crystals that does what's called Q switching. Okay, a regular laser is made by exciting a whole bunch of atoms with their electrons into a higher state, and then you put them in a cavity with mirrors on either end. And when some of them decay, they give off a photon, it bounces back and it causes more to decay, and you get this cascade. And so a regular continuous laser is you just exciting whatever's in the resonant cavity up, it's dropping the electrons down, they emit photons, and that's the stimulated emission, right? Q switching is interesting because you put something in the laser cavity that damps this down and keeps it from lasing. And what that lets you do is charge up. It lets you charge up, and in lasers it's called pump more of the electrons up into this higher state because the cavity isn't resonant. And then you switch it so that it is resonant, and blam, everything kind of avalanches and you get a really short but very high intensity pulse out. Because when it wasn't resonant, you're able to charge it up more, essentially. And then when it goes resonant, a lot dumps out. And here they're using passive Q switching. They actually have a material that doesn't resonate right, and then until it gets a certain amount charged up, and then it does. And to drive that, they have to have a special controller, and they have this actually built with an Arduino and a bunch of MOSFETs. But that's also a really interesting part of the build, because you have to like periodically hit the Q switch with the energy from the infrared laser, and then stop, and then hit it again, and then stop, and hit it again, and then stop, while the Q switch is going build up, fire, build up, fire, build up, fire. And all of this is on a kind of nanosecond time scale. So the timing's a little bit critical, but it turns out they can get it done with an Arduino and some MOSFETs. And so that's another super interesting part of this build. And there's really great safety interlocks, and the whole thing is in a box, so you're not going to go blind. And it's got an XY stage, and there's just a ton of interesting DIY stuff here. So if you're at all a laser nerd, or at least interested in seeing what goes behind serious laser designs, go check this out.
There always seems to be that hard stop with lasers and metal. The kind of lasers that we're used to putting on laser engravers and laser cutters and all that stuff. Wood, plastic, cardboard, paper. Yeah, great. Everything will fall to this laser, and then you'll get these beautiful cuts and all that stuff. Second you put a piece of metal in there, no matter what metal it is, it seems like no. It's just a no-go. Metal is not going to be cut. You're going to need to go to a fiber laser if you want to cut metal. So I was a little bit shocked, actually, that, it's copper. It is a metal. It's a very thin piece of metal, obviously, to be on a PC board like that. But still, I figured there would be some need for much, much higher power laser to get any headway with copper ablating. When I first saw this, I thought it was using, the old story of using a laser to do to etch away the photoresist, to do the photoresist, and then you etch it with ferric chloride or whatever your favorite etchant is. But no, I mean, this one's really, like you said, you're making copper gas, which has its own problems probably. It was neat to see that they actually made this work. And the nonlinear optics involved reminds me of a recent video from Les Wright that shows him growing nonlinear optic crystals. And it's as simple as any crystal growing, like if you've ever made rock candy. It's really just as simple as a solution of that potassium dihydrogen phosphate, I think it is, KDP. Getting a saturated solution of that and hanging a seed crystal in there and come back a couple of days or weeks later and pick out a nice crystal and throw it in the path of this infrared laser, and all of a sudden you've got a green laser. It's pretty spectacularly easy. I mean, if you happen to have a high-powered infrared laser at your disposal, which Les does, but and putting it to work, which is basically what they're doing here, for something as useful as etching PC boards not at home but at the Fab Lab, is really exciting, and I'm keen to see where this goes.
You mentioned along the way fiber lasers, and that's kind of the obvious comparison point here, because you can also do copper ablation with fiber lasers, and in the recent times, fiber lasers have gotten down into the kind of $3,000, $5,000 range. This isn't a cheap build either. It looks like this is going to set you back $1,500 or $2,000. Andreas actually comes in and says that in the comments here, that the point here is that this is a really cool laser design and you could build it. And if you want to play around with building a really cool laser from scratch, this is the project for you. If you really just want to etch some PCBs, first of all, there's a whole other bunch of technologies you can use. And second, these days anyway, you can just buy a fiber laser to get the job done. I agree with what you were saying also, that it's just amazing that you can ablate copper, because copper reflects infrared and copper spreads heat out really well, and it really doesn't want to get hot and boil off. And so the fact that they can do it is basically all down to these really short, really high intensity pulses. It's funny because the first version of this, Brian Cockfield wrote, he had, that the laser they were using was a 1.3 watt laser. And that's true, but it's a 1.3 average watt laser. When it gives you these like ultra short spikes, they actually are 50 kilowatt pulses. So,
Yikes.
It's not on much of the time, but when it is on, it's really way the heck on. And that's the Q switch working here. That's we're going to put all the power from this normal infrared diode, and it is kind of it's a 10 watt infrared diode, and it pumps this thing up and it puts out, only 1.5 watts on average, but bam, when it does, it does. And it's fast enough and hot enough that the copper doesn't stand a chance. It can't pass the heat off, and that little bit boils, and boom, you're done.
All right, next up for me is Hallback Array makes magnets strong or weak. And this one is a look at what it takes to make Hallback arrays, which, if you're not familiar, is a way to arrange magnets so that you can either constructively or destructively, I don't want to say it's interference as it would be like with radio waves or sound waves or anything like that, but basically you're alternating the fields in ways that will either make it a stronger magnet as a whole or a weaker magnet. And you could even, in fact, turn off the magnetic field if you arrange things right. We've seen Hallback arrays used in things like brushless DC motors. This is the first thing I thought of when I saw this. Is I remember writing an article a long time ago about a almost entirely 3D printed BLDC that used a Hallback array, and I hadn't heard of a Hallback array at that point. So I did a little reading on it, and as much as you can get your mind around magnets, because
Magnets, how do they work?
This is wannabe Mad Sci explaining how the Hallback arrays work and what the different arrangements are of polarity and what each one of them does. What is curious to me is, when playing with magnets as a kid, you're playing with one magnet and you think, well, that's cool. Look at it. I can move it around. I can stick it to the metal. Like, if you've got two magnets, your natural assumption is, oh, if I have two magnets, they're twice as powerful, right? And then you stick them together north to south and it's about the same. The magnetic field's about the same. However, if you align them correctly, which in this case is basically like a 90-degree offset of north to south, so magnets are oriented so that their north and south poles alternate on every other magnet, and then in between you've got a magnet that's rotated 90 degrees. Not only amplifies the magnetic field, but restricts it almost entirely to one side of the array. So you've got a side that's essentially not magnetic, but the other side is super magnetic. And that BLDC motor that I mentioned before used that to great effect by, basically keeping all of the magnetic field inside the lumen of the stator and having none of it on the outside. It's all kind of fascinating physics, and trying to get your head around it is maybe, depending on who you are, maybe more interesting than the practical end of it. But I mean, I particularly like the practical side of it. What you can and can't do with magnets is greatly determined by how you arrange them.
And it does seem like kind of magic, but like you say, it's not, because the deal is when you make a Hallbach array, you get a strong side and a weak side. So you're not making more magnetism. You're just like shifting it. And so it's, energy's conserved or whatever. Force, I guess, is, I don't know what it is with magnets. Potential, the field strength is conserved, right? Or is it? Ooh. Okay, I back off all that. Anyway, the point is he actually does the experiment here in this write-up, which I think is great. And he puts the magnets together, alternating. He gets 1.5 kilograms of force. Aligning them together, he gets 1.9 kilograms of force. But when he does it in the Hallbach configuration, he's got 500 grams on one side and 2.4 kilograms pulling on the other. And so it really is a big deal. It really is that, putting them in this kind of rotate the poles by 90 degrees configuration that Dan was talking about gives you a factor of 6 from strong side to weak side. So if you're talking about a situation where you only care about it sticking on one side, that's a huge, huge win. And I guess the application here is a magnet to hold letters onto a refrigerator door. I'm not sure that's exactly the most demanding application I've ever seen, but now he can stick more letters to his fridge.
Probably a week's worth of junk mail.
Or something.
Yeah. And I think that's important to note, too, is that this is not just something that you can't just stick magnets together like you would north, south, north, south, north, south, and they'll stick together themselves. You've got to restrain them physically, either with like epoxy, or in this case, he made like a 3D printed jig. And you've got to overcome some of the resistance. These magnets do not want to be doing this.
Exactly.
If to anthropomorphize it a little bit, they don't really want to do this. But if you force them into positions with some sort of jigging, then you can build these arrays.
This week in Quick Hacks, I had too many and I just couldn't pick them. There are just too many cool hacks this week, so I'm going to go as fast as I can. Everybody gets one sentence. Starting with Alan Reiner's Sloth door greeter uses neat fold-up electronics enclosures. This has embedded hinges, but also zip tie anchors everywhere, and he uses that to mount his electronics to. Check out other coverage of his Welcome to Zip Tie City. Link in the show notes. Next up, Maximilian Cairn, Hackaday prize entry, O-Mote Universal Remote. This is so slick. It's got a touchscreen. It's based on the ESP32. Thanks to the LVGL library, it's got an accelerometer switch. This is the remote to end all remotes. Some science from Hyunjung Jung and company, improving ocean power with static electricity. This is a static electricity generator that uses aluminum magnets and, I kid you not, rabbit fur to generate static electricity. Air Pockets Hackaday prize entry, tilting mechanical panels make a beautiful display, is far too many servo motors and just far too fantastic to watch. Crive's remote code execution on an oscilloscope. He manages to get the web interface of a Rigol scope to allow him to change the root password. Spooky Ghost adapter board expands the Pi Zero. If you can't get a Raspberry Pi, but you need the form factor, this lets you plug a Pi Zero into it and builds all the expansion ports. And last but not least, Aaron Christoffel's sniffing passwords, rickrolling toothbrushes. When you have a toothbrush with an NFC head, you have to figure out what its password generating algorithm is, and he reverse engineers the firmware to do it.
Oof. Man, nailed it.
It's not my fault. There were too many good hacks.
My 3 quick picks are, first of all, awning motorized and automated to avoid wind damage. These are window awnings that you'd use to shade your house, shade a little patio area, something like that, add a little outdoor living space. The problem is with these things, they don't like wind, and you're going to find them across the house or across the neighborhood if something goes wrong. So instead of suffering that fate, Steve Carey built a motor to automatically retract his awning when an accelerometer out at the edge of it starts to detect it wobbling around too much in the wind. Next up, taking mechanical keyboard sounds to the next level. Everybody, well, probably not everybody, but I love a clacky keyboard. And this one takes the clacking and the dinging to the next level. You might remember back in the day that typewriters had a bell when you got to the close to the end of the line. Well, now your electronic keyboard can have a similar feature. And the first thing this put me in mind of was the typewriter song. If you like that one, there's a link in the doobly-doo. And there's also a link to another keyboard that uses a solenoid to recreate the typewriter-like sound. And last up, reverse engineering reveals hidden API and abandonware trail camera. Chris Jones scored a cheap camera off of eBay that was designed to go on a tree and take pictures of wildlife. Unfortunately, most of the functionality was locked away in a sort of a janky app that had to go on his phone. Not wanting to do that and to maybe add some functionality to this camera, he did a lot of reverse engineering and revealed a few of the hidden functions inside the API, and he's on his way to building kind of a bridge for this camera to go between the internet and bypass the janky software that he would have to use otherwise.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And last week, Al Williams wrote up an article about how duct tape became famous. He starts off with the interesting historical anecdote conjecture, I guess. I don't know, but this is like so controversial that duct tape used to be made with cotton duck, which is the name for that kind of thin cloth-like stuff. And then it had rubber spread over it, and that was the tape they used. Only later would it gain an adhesive on it, and this is when the duct tape that we know and love came to exist. And this was during World War II, and this was the part of the story that I didn't know and I thought was just fantastic. A woman named Vesta Stout was packing ammunition boxes and wanted them to be easily openable. And so she decided to stick a kind of, I guess, heavy stick but easy to remove glue to the cotton duck and to seal the boxes with it. Her management said no, and she wrote a letter to President Roosevelt and said, "We need this to seal our ammo boxes." And he passed it along to the War Production Board, and they loved her idea, and duct tape was born. And what? How can you have an invention and then write the president and then it works? Like, that's just the best. That's the best origin story I have ever heard. And, you know, then of course there's this company bought this company did that, you know. You can read about it being misnamed to duct tape and then back to duct tape as a funny brand. And, you know, the rest of the story is amusing. But I just love the fact that it had its roots in this kind of, hey, wouldn't this be a great thing to do? And the manager saying no. And she not only goes over her manager's head, but she writes the president. Like,
That's the entire chain of command. Skipped everybody.
That is brutal. And she wins. So, if you didn't know the name Vesta Stout, now you do. And she is my new hero. The other thing that I thought was fun about this is there is a link to some recent study that confirms everything I know, which is that duct tape gets crappy when it gets hot. And if you have HVAC ducts, the only thing you shouldn't use for them is basically duct tape, because the glue on that stuff is not meant to hold up under repeated heating and cooling cycles, and is just going to get sticky and come off. And frankly, if you're ever going to take it off, don't use duct tape, because we've all removed that glue, right? It's just horrible. And in fact, leave your favorite duct tape adhesive removal solvent you can use for that in the show notes, because I can't even remember what I resort to. Kerosene, probably. Like, it's
WD-40 does a good job.
WD-40?
Yeah, for the win.
Yeah, okay. That's kind of the yin and yang of bad home working, right? Is duct tape and WD-40. Yep. So it actually makes sense that the one would work against the other in exactly that way. Anyway, if you have to seal ducts, use appropriate aluminum high temperature tape. If you have to glue ducts to things, then duct tape's what you want.
It's convenient that it's duck and duct, because if you're going to piss someone off, no matter which way you say it, at least you have plausible deniability. Oh, no, I said duct. Oh, you said duct? No, I said duct. Well, okay, you say you can always weasel out of it if you don't feel like having the argument with GIF. I mean, it's a little harder than with GIF and GIF, but but I always referred to it as duct with a T tape, right up until the point where I would, see it hanging in tatters from a duct because it dried out, and and all you see is the remains of the crystallized remains of the adhesive, and then there's this piece of fabric or plastic or whatever it is hanging down. So yeah, I know that it's not useful for a lot of the things that I can't even think of a roll of duct tape I have in my house right now. Probably got one somewhere, but I mean, I don't use it that much, and that seems a little weird. It seems like it should. Now I'm wondering if I've even got a roll of duct tape in the house. I'm gonna have to go look. There's got to be one around here someplace. But and just in general, I'm noticing tape is extremely expensive. All kinds of tapes, like especially the blue tape you use for painting, the Scotch, ridiculously expensive if you go to buy a roll of that in Home Depot or something like that. And I don't really understand why. The video that Al includes in the article kind of answers some of those questions, what the process is in making tapes. There is a lot of engineering that goes into something like that, and they're probably getting paid for that. But I still think there's just a huge markup on tapes in general. I don't know if it's necessarily justified.
I tell you, I used to think like that, and I am totally won over. I had a friend who did woodworking, and instead of using clamps, he would tape all his joints together, and he had a particular favorite tape for this. It was just a clear packing tape, but it had just the right amount of stretch to it. Like, imagine you're making a 90-degree angle in a frame or something, right? And you've got mitered corners.
Yeah.
And so you tape them flat together, and then when you push it together, it gets just that little bit of extra pressure against it, and the tape is just stretchy enough that it has clamping force on the joint. And he would put these things together better than I've ever seen anyone clamp them, and in an 18th of the time, just because he used the right tape for the job. And I was asking him about this, and he's like, no, feel how it stretches. And I'm like, oh, damn it. And he's like, you think of this as tape, but for me, this is a tool. And I'm like, uh-oh, this is trouble. And since then, I've had to do some high temperature stuff, and I bought this really neat high temperature adhesive polypropylene tape. And so the polypropylene holds high temperature, and then it's got this adhesive on it that doesn't give up. Parts where you would normally have to, make screw fits or something, you can actually just tape together if you have the right tape. Kapton tape, I think, for a lot of hobbyists, 3D printer enthusiasts especially, has been kind of one of those revelations as well. Tape can be a tool. And the difference between gaffer tape and duct tape is another one of those where gaffer tape doesn't leave gooey crap on afterwards. And my introduction to that was setting up for a Hope conference a million years ago. And the goons from Hotel Pennsylvania were like, you can tape anything anywhere you want as long as you use gaffer tape and only gaffer tape. If we see any other tape on the walls, you are in deep doo-doo. And that's because they didn't want us pulling the paint off their walls for some reason. I don't know. But like, these were serious rigging dudes, and they were very serious about the tape we used. So I don't know. I have tons of respect these days. That said, I've also like repaired a hole in my pants pocket with some duct tape, and it held up through I don't even know how many washings. So that stuff has its uses too.
It's funny you mentioned the tape engineering. My first job out of grad school, I'm working for a biotech company up in Massachusetts, and we had these microtiter plates. We needed to seal them, and they came with lids, but handling the lids was kind of a problem for the robots that we were trying to build. So I came up with the idea, well, why don't we just get like a tape dispenser or something like that? And I tried that with just a plain old roll of tape, and it sort of worked, but it wasn't the right size. And somehow I got hooked up with a rep from a tape company. It may have been 3M. They make a bewildering array of products anyways. I don't know who it was, but this guy came in and there was nothing that guy didn't know about tape. He knew absolutely everything. And he took one look at my problem. He was like, oh yeah, no problem. We can, we can custom cut, this, and we can kiss cut it between. And I was like, kiss cut? Oh. And, you instantly knew what kiss cut was. You had a backing. The blade would come down just enough to nick the plastic. Kiss cut. Makes sense. So now I know, now I know this word, kiss cut. And like, I can talk the lingo, and he talked about the adhesives and UV damage and heat and stability and nothing he didn't know about tape. And I left that meeting just like astounded that anybody could basically build a career around tape, but he did. And I was ready to give him a ton of money. Okay, my pick is also an Al Williams piece. Hats off to Al for sweeping the category today. This one's an Ask Hackaday, Learn Assembly First, Last, or Never. As soon as I read the title, I had the answer. I knew the answer was going to be, well, first, of course, because I learned it first. Well, then I started thinking about it. I didn't really, and I'm going to say right off the bat, I am not an assembly programmer. I don't do that, but I can read an assembly program and understand it. I can appreciate it. I can kind of debug it. But I couldn't sit down and, and crank out code in assembly language. And I know there are people who can do that, and I respect that immensely, but it's not something that I do. However, the first computer that I programmed, in answer to Al's question in the title, I did program in assembly language. It was not, however, the first programming language I learned. That was BASIC, and that was on a TRS-80, but not a real TRS-80 because, we couldn't afford such an extravagance back when that first came out. So basically I wrote my basic programs on paper and executed them in my head and learned how to think programmatically without ever touching a computer in the first place. Later on, the first computer that I actually got, which was an 1802, an RCA Cosmac, I don't remember, VIP, I'm not sure of the exact designation there. I can remember it, and I've looked it up since then, and it was a great little single board computer with an 1802 processor, and you had to program it either in chip 8, I think was the language, or you could program it in assembly language. And I remember poring over the manual and looking at the codes, the instructions, and knowing, okay, well, this is going to put this value into this register, and then you're going to shift it out onto the stack and all that stuff. And the first programs that I actually wrote for a computer were written in assembly language. So I guess that's my answer to Al. Learn, and someone even said this in the comments, learning some kind of computer programming first teach you how to think like a computer, and then add specifics on like assembly language, so you know what the machine is doing when you give it that higher level language. The comments, there's 142 at this moment. As you can imagine, opinions are strong. Al makes a lot of good points about which one it should be. The case for an early intervention in assembly language is, like I said, it teaches you to understand what's going on at the CPU level, and things like C pointers become trivial when you understand exactly what's going on in the processor. On the other hand, are you kind of jamming your brain into a processor specific set of instructions that doesn't really translate to another machine? And then you have kind of the added difficulty of modern CPUs being considerably more difficult to kind of break into assembly language on versus a 6502 or a Z80 or like I did in 1802. I still think the right answer, if I may be so bold, is to learn how to think programmatically first with BASIC or JavaScript or C or whatever, and then kind of step back, get yourself an old retro computer, a 6502, build a breadboard 6502 like Ben Eater does, and then then you've kind of got the best of both worlds. You've got the ability to think programmatically and the ability to understand what's going on in the compiler, what's going on in the processor, and I think you get a deeper understanding that way. That's my final answer.
I totally agree with your final answer, which makes for a lousy counterpoint. I'm old, but I'm not that old. I also started off with BASIC and then moved on to C and only learned assembly kind of later in life, as it were. And so, if it's learn assembly first, last, or never, I picked the fourth way, which is kind of somewhere in the middle, right? But I also agree with you that it's important. There's not just one assembly language. Every processor has its assembly language. And that was kind of the reason higher level languages were invented, after all, was just to tame the language zoo. But I really learned assembly when I got into doing embedded stuff. And I think that is, these days, the really nice, comfortable middle way is that a lot of microcontrollers are designed with a nice assembly language. And because the kind of things you're doing are often low level enough, it fits the task well. But because the parts are designed to have a workable assembly language, the tools are easy to get the job done. And so I'm thinking of like the AVRs, the MSP 430s. It's funny, I was just talking with Voya Antonich the other night, who has a particular favorite pick, and he's going to kill me for not remembering which one it was, but he's like the assembly language on the, I think, PIC 32, but it might have been the 16 series, might have been the 24s, is particularly beautiful to program in. I'll tell you what isn't. I'll tell you what's an absolutely horrible embedded assembly language is the ARM ones, the Thumb series, especially the Thumb 2 thing that you get on like the ARM M4s these days and stuff. Oh, brutally horrible to program with. The mnemonics aren't mnemonic, and they have 16-bit and 32-bit sizes, and it's all jumbled together. Absolutely horrible. I've heard people say things, everybody's got their favorite chip to program on, but both yours and Al's is the 1802.
Yeah.
So
you mentioned that too, yeah.
You guys share that. And I think if you're going to do something modern, so any of the microcontrollers, any of the microcontrollers with nice assemblies, so AVR, MSP 430, whichever pick it is that Voya likes. Or you have an even cooler choice these days, which is to go to RISC-V, which has a very simple instruction set. I guess because it's so simple, it makes you do more of the thinking yourself. But I think that's part of the thrill of learning assembly language is that you get to / have to do some of the thinking that, otherwise would get done for you by the higher level language. And I think that has some value too. I totally agree with you. I think that somewhere in the middle is probably the right way to do it. Learn to program first and then learn assembly language eventually.
It's funny that you mentioned embedded systems like that, because I just had a glimmer of recognition of reading a Dr. Dobbs journal article from years ago, and it may well have been Al that wrote it about embedded systems. It was a column, an embedded systems column. And I mean, this was ages before I'd even heard of it was before Hackaday existed. It was like, this was in the 90s. So Al, maybe I've been a fanboy of yours for a long time.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow the links or leave a comment, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us a line, tips@hackaday.com. And until next week,
Keep on hacking. Where's the wave? There it is.
if you didn't win this what am I even doing? It's going to be one of those days, dude. What is the actual laser word?
8?
I couldn't pick one this week.
Okay. All right. I'm going to go to the bathroom.
I can't blame you. I'll need to after I'm done with this. Tell me I was recording this whole time?
Please, I was recording, was I?
Literal mic drop.